next team presenting today is 15083 Overclock from Allen, Texas. Overclock thrives on precision and innovation. Achievements include the Control Award at Kentucky's Run for the Robots premier event, Design, Think, and Control Awards throughout their season in Texas tournaments, and a finalist alliance run at the Texas UIL FTC State Championship. And they'll be presenting about the beginner's guide to prototyping.
Hi guys.
Hi everyone, we're Team 1503 Overclock, and we're going to teach about our presentation, Intro into Prototyping. Now, what is prototyping? Prototyping is the process of creating a preliminary design in order to test a new idea and experiment with new things throughout the season. We know that Into the Deep wasn't a season where one thing always worked. So it's important to know that even if it's halfway at the beginning or even at the end of the season, which we soon found out, which we'll share later, it's always good to have a backup plan in a way to implement new ideas quickly and effectively. Now, what steps can you take when you want to prototype? Well, we narrowed it down to 5 main steps, and we followed the engineering design process when we did this. First, defining the problem and specifying the requirements, brainstorming around that problem, creating design, evaluating the design, and last of all, iterating around the design, no matter how many times it might take.
Okay, so let's talk about our motto, fail fast, which we developed this season Into the Deep. So basically, if you think about a competition model, it's like 3 league meets and 1 tournament in a short amount of time. So you want to get to your final design as fast as possible so you can do well in the competitions, right? That's why you do fail fast. You get a lot of ideas on the table as soon as the season starts and rapidly prototype them in order to find the best solution so you can iterate it and refine it, which we'll go over later. So this is a general timeline. First, you should take 3 days for brainstorming, so you come up with the ideas and put them on paper, which Tito will go over later on. Then you do the fail fast method, making those prototypes as fast as possible through the methods we're going to talk about later, and then refine that idea for better results.
So like my good friend Gene talked about, right after kickoff, you're going to want to get your ideas straight from the brain onto the paper. So usually you're either long or small groups, right? And you're just kind of sketching down the ideas, and then eventually after that, you get with the big group, and you go all bounce your ideas off of one another. So ideally, you're gonna have like a ton of ideas, right? So then how do you choose which idea is best? Well, at Overclock, we like to use this thing called the decision matrix. The way this works is you'll get all your prototypes, right? You put them at the top of this table here. Next, you're gonna get certain criteria or traits that you'd like your prototype to exhibit, and you put them on this side of the table here. So each team has different traits that they tend to prioritize more. Here at Overclock, we like to use an acronym that is called METER. It stands for modularity, expenses, time, endurance, and reliability. Now, with each of these traits, you're going to weigh them differently, and it sounds a little bit confusing at first. So let's use an example. So modularity, we quite enjoy that at Overclock after learning from our experiences. So we're going to weigh that at 3, and then we're going to score our prototype from a scale of 1 to 5, and for example, on prototype 1 in modularity, you got a 2. So we're going to multiply 2 by the weight of modularity, 3, right? We're going to get 6. We're going to do that for all the traits down here, and eventually we'll get a score of 34, which means that this is mathematically our best solution. Next up, I'm going to talk about modular prototypes. At Overclock, we actually really like using modularity because I'd like Jonathan to explain.
Yeah, so Overclock recently went to the Kentucky Premier event where we ran into a bit of an issue after competing in our qualification matches. You see, our robot Cypher over here is actually quite a strong robot. However, one of its main downsides is that if its arm, which is right here, were to break, it's almost impossible to fix it without having proper, 3D printed replacements for it, which we so woefully encountered in our playoffs matches where we lost both of our lives within the first 2 matches.
If it was modular, what we would have done is just hot swap it with the subsystem that we already did, because it's all 3D printed, right? It's really easy to make a hot swappable version that we just slap on as soon as something breaks.
Now, it's on the previous slide, but it's fine. One quick note I want to make sure that everybody knows to remember is please try to standardize the type of screws that you use, especially on the drive base. Sister team of ours forgot to do that, and now their team lead is like a minimum wage at McDonald's or something. So, yeah, please standardize your screws.
Okay, let's talk about CAD and utilizing 3D printing. You have a lot of ideas from the brainstorming that Tito talked about. So now we want to make those prototypes in real life and test them out, right? So that's why you use CAD. In CAD, you can design models and see how they work. Because sometimes the ideas are really good. They work out well in theory, but the geometry and the rules don't work out well. So that's why you want to make it in CAD. And a specific feature that I want to talk about that's found in some CAD programs like Fusion, Onshape Premium, and also Solid Edge is FEA, Finite Element Analysis. And it allows you to put a force on a part or subsystem to see the failure points or the stress points. So you can change it accordingly, even before you 3D print it or make it in real life. So it's like cheaper, which is basically no money. And you can also do it before 3D printing, which saves time.
Now,
go back to one.
Yeah.
And also utilize 3D printing. As you can see, all the black and green parts on a robot is 3D printed. So 3D printing allows your prototyping phase to be fast and cheap, because all you need is a printer and your brain, right? And it allows you to make all sorts of parts that you can test out at the start of the season, which goes into our fail fast method.
Well, now that we know we want to prototype and 3D print those prototypes, what materials can we use to actually do it? Well, throughout the season, we use two main materials, PLA or PLA Plus and PETG. We realized early on that we wanted to prioritize modularity and fast, efficient printing. So we use PLA. However, now that the season's over, we can quickly realize that PETG might have been the better option because of how strong and durable it is.
And on that note, selecting materials is an important part of the engineering design process. For example, our robot, which is mostly made out of 3D printed parts, needs a strong infill on the inside so that way it doesn't break if another robot were to hit it. A part that has a functional purpose would need to be more strong than a piece with an aesthetic purpose. It's also important to make small changes to each part of your prototype. You don't want to make a large change because that leads to the effect that you may not be able to complete your part in time for your competition. So you should consider what your current prototype can do and how small changes can improve them. Finally, it's important to add all of your changes to your marketing materials. The judges don't just want to know what your final product was and how many points it gets for, but how you got there, from your original concept to your final product. They want to know each and every step that you took. So these information should be placed inside your engineering portfolio and your marketing presentation to show the judges how much you've learned and how much you've improved.
Well, thank you for listening. We've been 15 Overclock. If you have any questions, please feel free to reach out to us on our Instagram or thank you.
We'll be right there, back there.
Okay. We're actually running behind, so if y'all have any questions, you guys can ask them later. Probably they'll be okay. Great.